Hi guys, welcome back to NextOps channel. In the previous video, we discussed about VNet and SGS as part of implementing and managing Azure Virtual Networks. In this video, we will learn about routing tables. If you haven't subscribed to my channel yet, please go ahead and do it now to receive the new video updates via notifications. And do not forget to click on the bell icon. Before we move on to technical discussion, a little bit about myself. If you want to reach out to me, please contact me through my blog or send me a connection request on LinkedIn or leave a comment on my YouTube channel. If you want to find my videos on YouTube the easy way, then use the keywords displayed here. Alright, let's get started. One more last thing, if you haven't watched previous videos about VNet creation, VNet options and network security groups, please go ahead and watch them before watching this video, as it makes more sense if you do so. Let me explain routing tables in detail. Before we understand routing tables, let's understand what is routing in networking. Routing is the process of selecting a path for traffic in a network or between multiple networks. Broadly, routing is performed in many types of networks, including circuit switched networks such as public telephone network and computer networks such as internet. Take a look at the image on the right side. I just took a simple example of route directions from New York to New Jersey in real world to explain routing. As you can see from the image, to go to New Jersey from New York, Map service has suggested us two routes. The calculation of best route will be based on the time and distance it takes for complete travel. The same way in a computer world, a computer chooses best path to send its network traffic using routing process. As I described here on left, the routing process usually directs forwarding on the basis of routing tables. Let's understand what is a routing table first. Routing tables maintain a record of routes to various network destinations. Routing tables may be specified by an administrator, learned by observing network traffic, or built with the assistance of routing protocols. So, which means a network administrator can create the routes, or they can be automatically created using the BGP protocols. As you can see below, this is how routing table looks like. It gives you information about source and destination for a packet along with gateway that it needs to travel through. Azure automatically routes traffic between Azure subnets, virtual networks, and on-premises networks. Azure accomplishes this by using system routes. If you want to change any of the Azure's default routing, you can do so by creating a routing table. And Azure automatically creates system routes and assign the routes to each subnet in a virtual network. You can't create system routes, nor you can remove them, but you can override some system routes with custom routes. In other words, user-defined routes. As you can see from the table below, this is how system routes looks like. If you can remember from the previous video, we have created a virtual network and we have created a subnet inside that virtual network and also associated it with network security group so far. So in this video, we are going to create a routing table and associate it with the same subnet that we have created earlier. And Azure also adds additional optional default routes to specific subnets or every subnet. When you use specific Azure capabilities like VNet peering, virtual network gateway, and virtual network service endpoint. What is VNet peering, VNet gateway, and VNet service endpoint? I will discuss about them in detail in upcoming videos. So please subscribe now. Let's take a look at how a custom route looks like. A route contains following values: a unique name for the route within the routing table, an address prefix insider notation that you want to route traffic to, that is the destination basically, and next hop type, and an IP address for the next hop address. You can only enter the address if you selected virtual appliance for the next hop type. You cannot enter the IP address for any other next hop types. In order to create a custom route, first we need to create a routing table and then add a route. Let's go ahead and do it now. Let me switch back to my portal and open the routing tables blade so that we can create our first routing table and add the respective custom routes to it. Here in my routing tables blade, and I'm going to add my first routing table to this deployment. I'm going to attach it to my public subnet, so I'm naming it as pubsub rt01. As we have named our NSG as pubsub nsg01, I'm naming it using the same naming convention, and I'm placing it in my RG01, and location would be East US. I'm going to create it right now. So virtual network gateway route propagation. What does it mean? If you have an on-premises router and you want to connect it with your virtual network, then you need to create a virtual network gateway in the first place. Once you create the virtual network gateway, it becomes a gateway for your virtual network on the Azure side. Then you need to connect this virtual network gateway with your on-premises gateway using the site-to-site VPN tunnel. Once you establish the site-to-site VPN tunnel, on-premises gateway will advertise its routes automatically using the BGP protocol. If you want to propagate your virtual network gateway routing table to the on-premises router, then you need to enable this option using the BGP if you want to propagate them. For now, let's keep it disabled and create it to make it simple. So let me pause this video here. Once the routing table is created, we can resume back. Okay, our routing table has been created now. So let's go ahead and add a route to it by clicking on the routing table and clicking on the routes under settings. We can add our routes. So as I have described, every route has these values: a unique route name, an address prefix in the CIDR notation, and the next hop type. You have multiple options to select from, and next hop address, and this particular field by default is disabled for network gateway, virtual network, internet, and none. When you select virtual appliance, it will be enabled. So what is a next hop? I will describe in just a second. So let's fill up these details right now. 10.1.0.0. Assume this is something your on-premises network. I'm sorry, I kept it in a wrong place. So what I'm going to do is I will name this particular route as to on-prem network. So it is more meaningful to me, and on the on-prem side I have CIDR notation of 10.1.0.0/16, and I can use my virtual network gateway as next hop to reach to this network from my Azure network. So that is the only way that we can establish connectivity from Azure to on-premises, because we use virtual network gateway as the gateway on Azure end to establish the site-to-site connectivity to the gateway on the on-premises end. If you want to choose another next hop type here, for example virtual appliance, and you need to give a specific IP address of the virtual network appliance here, so that your traffic will be routed using this particular appliance. So let me explain what are all next hops are available here. What is virtual appliance? First of all, so treat this as a proxy server or a virtual machine that has been prepped up with this some kind of filtering software to filter your network traffic. So you can get any of the virtual appliances from Azure Marketplace and use it as the virtual appliance here. So once you deploy a appliance from Azure Marketplace, it will be assigned with a IP address. So what you're telling Azure to use this virtual appliance is, if you want to reach out to this particular network from Azure, then the traffic should go through this particular virtual appliance using this IP address. If it is internet or any other kind of destination, then there is no need of specifying the IP address here. Azure will take care of it automatically. So the next type is virtual network gateway. As I mentioned, this is the gateway for our virtual network, and it sits inside your Azure deployment. And this gateway is useful when you want to establish connectivity to your on-premises. There is one more option called express route. That's a different story, dedicated connection from your Azure to on-premises using your local service providers. But when it comes to virtual network gateway, you will be using internet as the backbone and connecting your virtual network gateway with your on-premises router. In this case, there is no need of providing IP address here. This field is disabled entirely. And once we add this particular route, any traffic that is originating from our virtual network or subnets to this particular network will go through virtual network gateway. In a similar way, whatever you choose from the NextOps type, that will act as the gateway to reach out to the destination network. And if you want to drop the traffic to this particular network, then you need to use none as the NextOps type, so that all the traffic that is destined to this particular network will be dropped. This way, we can block the network traffic to a specific CIDR notation. And then virtual network, internally Azure creates routes to establish communication within the subnets or between the virtual networks. If you want to override that particular route being created by Azure, then you can actually use something like this. Create your own route, custom route, and all the traffic to the destination network will use the virtual network as the NextOps type. So there are so many real-time examples provided in the Azure documentation if you want to look at. And also if you want to redirect your internet access, or if you want to reach out to a specific public subnet on the other side of the world, then you can use internet as the gateway to reach to that particular network. So what we are doing is we are creating a route and telling Azure to use this particular gateway or NextOps to reach to this particular destination. Here source is Azure network, Azure virtual network and Azure subnets. And destination we are mentioning as address prefix, that is the destination network that we wanted to reach or communicate with. And NextOps is the middle guy who actually establishes the communication from source to destination. So which one you wanted to use depends on your scenario. So virtual appliance, again, it's a virtual machine available in marketplace to filter out your network traffic or anything like that. So you just create a virtual machine out of your marketplace which has the monitoring software. Once it has been deployed, it will be allocated with our IP address scheme from the Azure, and the same can be given here, so that from your Azure subnet or virtual network, if you want to reach out to a specific network outside of Azure, then all the traffic should go through this particular virtual appliance, so that it will be monitored for the vulnerabilities. That's how we can use virtual appliances here. So this is all about NextOps types. Let's move on with the creation of our first route. And then remember, only virtual appliance has the IP address field enabled. Rest all will not allow you to give the IP address. So I'm just leaving it as it is, and I'm creating a simple route here. Like I wanted to block my access to this particular network. I'm clicking on OK. This will create a routing route for us, and this is called as custom route basically. And this routing table is not been associated with any subnets as of now. So to associate this routing table with the subnets, we need to go to the subnets under the settings of routing table and associate it with our existing subnet. So that is pubsub 01. So now this got associated with the subnet right away. So let's see other options available here so that we'll move back to our slides and discuss the rest of the things. So under settings, we have configuration. And if you want to enable the virtual network gateway route propagation, you can do it from here. So you will understand this particular option when we create the virtual network gateway. So what is the purpose of virtual network gateway and how it is useful to connect to the on-premises networks? I'm going to discuss it in the next videos in detail. So where I will discuss about this network route gateway propagation. So as I mentioned earlier, if we use BGP border gateway protocol on the routers, um, the router will advertise its already configured routes to the remote peer router. So the other end router will actually add the same routes to its routing table. Manual overhead will be reduced. So the same way, if we want our virtual network gateway that sits on the Azure side want to propagate the routes created to the on-premises router, then we need to enable this option. And we have routes, that's what we have created just now, and subnets. We have associated our routing table with the subnet properties. These are all resource IDs and other stuff basically. So it's taking a bit to load the information, it seems. Yeah. And then logs, it is to protect this particular resource from accidental deletion. So we need to add a log here. So I'm going to discuss about these things in the VNet options that we have left over. So just stay with me. The one more thing I wanted to discuss before we move on to the next slide is effective routes. The effective routes for each network interface is attached to a virtual machine are a combination of route tables that you have created. The effective routes for each network interface attached to a virtual machine are a combination of route tables that you have created, Azure default routes and any routes propagated from on-premises networks via BGP through an Azure Virtual Network Gateway. So these are the system routes basically. So these are all generated by Azure. Here we can see all the system routes. And the last one is the one I have just created. In the same way, if we have any additional routes being propagated from the on-premises router using the BGP, then they will appear here. So when we have discussed about NSGs, we have looked at effective security roles. In the same way, effective routes is useful when you want to look at the routes getting propagated from multiple sources. The routes that were generated by Azure and the routes that were created by the user-defined routes, and the routes that were propagated from the on-premises or any other router using the BGP protocol. So this way you can actually understand if there are any conflicts between routes, and you can actually take a necessary action to fix them out. So this is how we can actually create the routing table and add routes to it and look at the system-defined routes as well. So let's move back to our slides and discuss about an interesting topic called how actually Azure selects a route based on its destination IP address. When outbound traffic is sent from a subnet, Azure selects a route based on the destination IP address using the longest prefix match algorithm. What does it mean by longest prefix match algorithm? I am going to discuss with an example now. Let's assume that we have a routing table which has two routes. One route specifies 10.0.0.0/24 as the address prefix, and the other route specifies /16 as the address prefix. In other words, destination. And we have a machine with an IP address 10.0.0.5 on the other side. And from our source, if I wanted to connect to this machine, Azure has to select the best route out of the two routes that we have specified. When you look at the CIDR blocks 10.0.0.0/24/16, Both of them belongs to the same network. In fact, /24 is a subnetwork of /16 network. If you can remember from our first VNet creation session, in which we have created a VNet with 10.0.0.0/16 as the network address, and then we created a public subnet out of it using /24 as the CIDR block, which means the destination machine 10.0.0.5 falls under both CIDR blocks. But our routing table has two routes which specifies /24 and /16. So how Azure actually selects which route to be chosen to communicate with 0.5? It uses the longest prefix match algorithm to select the route and enable the communication. In this case, which one has the longest prefix and how to identify the longest prefix? So Azure selects /24 route for the communication instead of /16 route, because /24 has the longest prefix. Nothing but /24 network has 255.255.255.0 as the subnet mask, and /16 has 255.255.0.0 as the subnet mask. Between both of these, /24 has longest prefix, that is 3 octets are having 255, and /16 has 2. So using the longest prefix, it chooses /24 route to communicate with 0.5 machine. In the other hand, we have another example. The same source machine from our subnet wants to communicate with 1.5, which is on a different subnet. In this case, it chooses /16 route, the second route, instead of /24, because 10.0.1.5 definitely not falls under 10.0.0.0/24 network. It's a entirely different subnet, but it falls under /16 ultimately. So that is the reason why Azure selects /16 route to communicate with 1.5 machine. To make things more clear, I've created a diagram here which explains the things in real time. So here our VNet, which has /16 CIDR block, and we have a subnet created with the /24, and we have a routing table which has two routes. One is having /24, 0.0/24 and 0.0/16. On the other side, we have two machines which has 0.5 and 2.5 as the IP addresses. From the source, when it wants to communicate with 0.5, it chooses the first route, and to communicate with 2.5, it chooses the second route. As I mentioned earlier, this guy falls under this particular CIDR block, and this guy falls under this particular CIDR block. Based on the longest prefix match algorithm, it chooses the respective routes. So this concludes our session, and in the next video, I'll talk about rest of the VNet options. So please watch these videos in this sequence to understand the concept clearly. Also, please do subscribe if you haven't already to get notified when these videos are uploaded. Thank you so much for watching this video, and have a good day.